All right, hello everyone. Welcome to the last workshop of Cyber Academy Winter 22. Today we'll be talking about steganography. So sorry for the delay, let's jump right into it. All right, so just a quick overview about what we'll be going over today. So after we go over a general overview of what exactly is steganography, we'll be delving into some information about what exactly is metadata, which is very important to understand the concept of steganography. And then we'll be breaking into some of the different types of steganography as you see over here. So the goal by the end of today's workshop is not only you'll know what exactly is steganography, but hopefully you'll become your own sort of a stegosaur. So just to briefly overview what exactly is steganography. So steganography is the practice of hiding secret data within another form of non-secret data. So data could be any sort of file, such as raw text messages, images, videos. And the specific intent behind steganography is to hide the fact that the data you're sending within the non-secret data is being sent. So it is known that you're sending the non-secret form of data, such as maybe an image, but maybe what's not known is that you're hiding text inside that image containing a secret message. And so as our meme kind of shows, there are hidden messages everywhere. So just to illustrate this example a little bit, let's say you're in Super Mario World and you are Princess Peach trying to send a secret message to Mario, but Bowser is overlooking and watching your every action. So what you could do is you could send, say, an image file where containing a very just friendly message, nothing too strange about that. But when Bowser looks at it, he doesn't see anything unusual about the non-secret data. But what you can do is inside the data, you can hide a secret text message, help letting Mario know that you need help as Princess Peach. And so one thing I just want to clarify about steganography is how it's different from other forms of sort of hiding data and concealing that information. So a couple things steganography is not is encoding and encryption. So for people who don't know, encoding is when you convert, say, like a form of text into another form of text. Like one example here would be ASCII to base64, changing the different times of encoding of the specific data. But this is different from steganography because it does not conceal the fact that data is being sent. You're still sending the same form of the data that's not different. And similarly, in encryption, which is stuff like ciphers and cryptography, this doesn't conceal the data in another form of data, which is a very important part of steganography. And something that's very important to understanding how files are concealed is metadata. So what exactly is metadata? Well, metadata is data about data. So this could be information about the file specifically, such as maybe who created it, or what exactly the file type is, where it was created, when it's created, why it's created. And a typical form of metadata is EXIF data, which stands for Exchange Image File Format, which is a type of metadata for images. This is what a majority of digital cameras use nowadays. So some examples of information contained inside of EXIF data is time, date, GPS location, and resolution. So if you ever used, say, a Windows computer and you want to look at, say, the properties of an image, well, you can see that up in the right-hand corner over here, which is an example of metadata. Another useful tool is in Linux, the Linux command line, you can use EXIF tools, which you can see right in the center of the image. And this prints out some of the metadata contained in EXIF format of the image file. So why exactly is this important? Well, containing metadata can sometimes betray you. So a famous example is John McAfee, who you may know is the founder of the McAfee antivirus software. So he was at one point an international criminal wanted for killing this man by the name of Gregory Fall. And so a reporter conducted an interview with McAfee and took a picture using an iPhone 4. But iPhone 4s capture the metadata, specifically the GPS location inside an EXIF format. And so because of that, police were able to then take the image and then determine the GPS location of where it was taken, and were then able to capture McAfee. As you can see over here in the right, here's an example of what sort of GPS metadata looks like.
So I'm going to talk a little bit about just generic file steganography. A little later, we'll talk about steganography tactics or tools that are specific to like image files or audio files. But there are some things that we can do with just any sort of file. So hopefully you went to our file analysis workshop at the beginning of the quarter. And if you did, you would remember that files are sort of containers for bytes, right? All they really do is they hold some bytes, and it's up to a program on your computer to interpret those bytes in a way that maybe makes some sense to you, like as an image or as a video or as a Word document, something like that. Since files are just containers, we can sort of hide extra data inside those containers that maybe isn't necessary to what the file looks like from the outside, but is nonetheless hidden data. Of course, from the file analysis workshop, hopefully you remember about magic bytes. So those are at the start of a file. They identify what type of file the computer is reading, like an image, and specifically like a PNG or a JPEG or something like that. And oftentimes there are magic bytes at the end of a file as well, and those indicate when the computer should stop reading data. For example, I think a PNG image has what's called an I-end chunk at the end, and that indicates, hey, this is the last chunk of the PNG image. This is it, stop drawing and arranging pixels. You've got all of the information. And so what we can do is we can put something after those magic bytes at the end, or it's sometimes called like a file trailer, and that data will still be in the computer's file. And when you copy the file or send it, all that data is still included. But if you were to examine the file as it just appears from the outside, you wouldn't ever notice that data, because the program that you're using just stops reading at the end of the magic bytes, and it doesn't continue on to any information since the end. And one really interesting thing we can do, you can see this this diagram that I have here. That's actually a diagram of how a zip file is laid out, like a zip archive. Zip archives are kind of different from most files in that really most of the important information is contained at the end of the file. You can see the central directory structure there. That tells the program that's accessing the zip file what file entries are contained in the zip, their size, some general metadata information about them. And since it's contained at the end, zip files are actually read from the end backwards rather than from the start forwards, I guess. And so if we have, say, one sort of file that is read from the start forwards, like most files are, say a PNG image, and we have a zip archive, we can concatenate those two together, and then you can open that file in either type of program. If you open it with an image viewer, you'll get what looks like just a regular PNG image. And if you tell a zip archive manager to open it, then it will start at the end and it'll notice the zip data, and it can interpret that as a zip archive. Sometimes it'll give you a warning about, hey, there's a bunch of stuff on the front. I don't know what this is. I'm just going to ignore it. But you know that that's there because of what you've done to this file. And so I have a demo demoing exactly what I've just talked about. Well, actually, first, before I actually go to the demo, let me talk about some of these generically useful commands. So whenever you're presented with a steganography challenge, this list of commands are a really great list of commands to just start with, to try and get a handle on what sort of file you're looking at, and hopefully get some ideas on how you can actually find the hidden message. The first command is file, just file. These are all Linux commands, by the way. File and strings, I believe, come default in the kernel. Exiftool, binwalk, foremost, those you can all install with your package manager for whatever your distro is. So the first one is file. That reads the magic bytes and it determines what kind of file you have, a PNG, a JPEG, whatever. That's especially useful when you are given a file and you don't have a file extension. And of course, you probably haven't memorized what the magic bytes for hundreds of types of files are on your own. So that's where the file command is useful. EXIF tool and binwalk are two more that are, EXIF tool is used for extracting metadata, like Ben mentioned, and it only works on a subset of files because those are the only ones that have metadata included in their file formats. But for files that it does work on, that metadata can be very useful, and I'll show that in the demo in a second. Binwalk and Foremost are two that are somewhat similar. You can really get by with just one, but I'll demonstrate both of them. What they do is they look for embedded files within other files. So like that scenario that I mentioned where you have two files just concatenated together, and a normal program that just displays images, say, would stop after reading the first one. Binwalk and Foremost can both identify that there's more data in that file later on, and it can extract whatever that is. It'll also, identify the file type for you using whatever magic bytes there are. Strings prints readable characters. That's useful under some circumstances. Again, we don't have to embed an actual file within another file. We can just embed arbitrary data, and if that arbitrary data is just text, then strings can help find that. If we opened an image and just slapped some bytes on the end that spelled out a flag, then running strings would get us that long sequence of readable ASCII characters. Of course, that's useful because most binary data like pictures or images or video files don't contain long strings of data that can be interpreted as ASCII. Sometimes they will for metadata, but you just sort of have to learn to differentiate between what obviously looks like metadata, and a lot of times it'll include words that tip you off on that, and what is actually a steganographic message. Finally, the last one is hex dump. That's useful for dumping file contents in hex. If, for example, you wanted to identify magic bytes, or if you wanted to search for a specific set of magic bytes somewhere in a file, like say you knew that there was a PNG image somewhere in a file, except the file was like hundreds of gigabytes long or something. What you could do is you could use hex dump and search through that output for the magic bytes for the start of the PNG. That would work. I'll also talk a little bit about hex editors in general. All right, so for the demo, let's see. Cool. Okay, so what I have here is what looks like a completely normal image. It's a picture of a ship or a boat, but yeah, a ship. So this looks completely normal, and we can see that it opens just fine. I can open it from the terminal as well. We get the same thing. So this looks completely normal, and if we run some of those commands that I talked about, file ship.png, this tells us, hey, yep, this is a PNG image. Great, it's exactly what I thought. If, for example, we want to get some more information, we can run EXIF tool. EXIF tool gives us a whole lot of information that's encoded in this PNG. Some things like the name, well, that was kind of obvious. We didn't really need that. File modification time, probably could have gotten that from the file manager. But there are some things like PNG specific things. I'm not actually familiar with PNGs, so I don't understand most of it. But all the sort of stuff about like how many like RGB channels there are and matrix columns, stuff like that. That's all metadata that's included that helps the program actually display the file display the PNG file as an image. There's one really interesting line here, and that's this line, this line. And this says, it's a minor warning, and it says, hey, there's some trailer data after the PNG IN chunk. You might remember that I mentioned an IN chunk is supposed to be the last chunk in a PNG file. And so running EXIF tool here has actually told us, hey, there's something after the end of the PNG file. That's not a problem for displaying the PNG file. But since we know this is a steganography challenge, that's something that we might want to take a further look at. Of course, I know what this is because I created this challenge. So I'm going to take a look, and we're going to just try unzipping this. The password is just password, very secure. And hey, we've got flag.txt. So what was at the end there was a zip archive. But of course, if we didn't know that, and so we didn't know to immediately jump to using a zip utility, we could run something like Foremost or binwalk. Or actually, even before that, we could try strings. I'm going to limit this to things that are 6 characters or longer. And we see flag.txt a couple times at the end here. This indicates, hey, that's a file name. So there's probably some file embedded, which makes sense. That's what we were expecting. So if we want to use binwalk or foremost, we can use one of those. Use binwalk with the -e flag, stands for extract. Thank you. There we go, much better. All right, so yeah, so if you use binwalk with the -e flag for extract, it will actually extract the files that it finds rather than just telling you, hey, there's a file present, because you probably wanted to extract the file. So if you run binwalk -e, it tells us, yeah, some errors, but ultimately what we get is a folder that contains some extracted information. It extracts an empty file, but we don't really care about that because all we care about is the zip here. And what do you know? It's a flag. So yeah, and then foremost does the same thing. We can see it creates its own thing. Foremost extracts the PNG itself as a separate file, basically. It treats the entire container as if it were just a container of bytes, and it extracts everything in there that looks like it could be a file. So it pulls out a PNG. It, of course, pulls out the same zip. And in our text log, we can see, yep, it identified one zip and one PNG file. If you want more information for either binwalk or foremost, I recommend the man pages. You can just type that in. This shows you a list of all of the formats that foremost supports. It doesn't support everything, but it does support a good array of formats, as you can see here. And so if you have a file that foremost supports, it's a great tool to use. Otherwise, binwalk is another great tool, and that works on pretty much almost everything because it just scans binary data. And yeah, the E flag is the most important one to remember. It's right here to automatically extract. There's also a couple more advanced settings if you ever need to look at those, which are all detailed in here. But there's things to like specify a file offset to start looking at, or this -m matryoshka flag means it will search all of the files that it extracted for more files that it can extract from them. So if you have like a file that's embedded 100 layers deep, you could potentially find that. I've seen challenges like that before. But yeah, that's basically just a list of the options. I'm not going to go through them all there. But let's see. The last thing that I will go through is in a hex editor. So I have the same file open in a hex editor on my Windows partition. That was on a Linux virtual machine. So we can see at the start here, like I mentioned with magic bytes, we can see the magic bytes that indicate a PNG, of course. If we scroll all the way to the bottom, we can actually take a look and see right here, you can see IEND, which is of course IEND. That's the final chunk that indicates the end of the PNG file. Or actually, it extends a little bit, but that indicates the start of the IEND chunk. And then right here, or right here, we can actually see PK and a dot. Those are the magic bytes for a zip file. PK is, I think, named after the creator of zip archives, whose initials were PK. But we can see this entire section here is actually, this is a zip archive. Just these few bytes. It's very small because all it contains is one text file. And we can see like the names flag.txt in here a couple times, and that's what that strings command was extracting. So those, even though the zip file is encrypted because it is password protected, if it wasn't password protected, the entire file would actually be in there because it's so small. There's nothing to compress, so you would actually see the entire flag in there, which is why I added the password as just password. But since it's encrypted, we can see the encrypted data, but the file names are not encrypted. So yeah, so if you really, if none of those commands are doing anything for you, the ones that I just mentioned, you can't open it up and just browse through the raw hexadecimal. It takes, it's a lot harder to interpret. So those commands are really nice for just running against any challenge that you encounter. But if you need to, then checking the hexadecimal can give you some insights as well. All right. So yeah, so this is a great reference. It's in the slides. So when you're working on the challenges, take a look at this list of useful files. And I just recommend starting, you can start at the top or just pick whichever ones you want. But this is a good set of tools to start running against any challenge you encounter, to give you some sort of an idea of what the file is, and maybe some more specialized tools you can use depending on the file type.
All right. So I'm here to talk about image steganography. So in order to understand how we can hide information within images, we first have to understand how computers store images in the first place. So as you all probably know, the only thing that computers can really understand are ones and zeros. So pretty much every file you can think of is just some clever way of arranging ones and zeros to actually store information, and images are no different. So the way that images generally store the way that computers generally store images is with 3 channels of information, one for each color, red, green, and blue. And each pixel will just basically have a number from 0 to 255 to represent the amount of red in a pixel, the amount of green in a pixel, and the amount of blue in a pixel. And with just these 3 different colors, we can actually represent about 16.8 billion different colors, which is pretty amazing. And some of these colors are very similar to each other, which can be very helpful for us in terms of hiding information. So an example here is 2 different colors where they only have 1 different bit in them. So out of those 16.8 billion colors, these are basically as close as you can get to each other. And basically what it is it's just 2 versions of red where the red channel in one of them is just 1 less than the red channel of the other one. So if you look here, you can see that the binary for the red channel is just all 1s for the one on the left, and then all 1s and 1 0 for the one on the right. And that last bit, which is different, is called the least significant bit because it makes very little difference. For example, if you change the first number, it would change, or if you change the first 1 to a 0, it could cut the number in half. It could go from 255 all the way to down to like 128, but changing the last bit changes it only by 1. So an example is that, or basically what this means for us is that we can hide information in them because the human eye is really bad at picking up on these really small differences between colors. So what we can actually do is we can take the last bit of each pixel and we can just overwrite it with whatever data we want. And then we can actually hide like pretty much any kind of data that we want that you can represent with binary within any kind of file. And pretty much if you do this with images, there's almost no way to tell that there's a difference if you use a small enough file. If you use really, really big files, you can start to tell. But if you look at these 2 images, pretty much nobody is ever going to tell that there's some massive file hidden inside of this image. Okay, so how can we actually do this though? There's a few tools you can use. One of them is Steghide. This one comes by default on Kali, but you can install it using your package manager on your computer, or if you want, you can build it from source. So it only supports JPEG and BMP and WAV files. It also supports AV files, but it doesn't support PNG files. That's really all you need to take away from that. And then pretty much what you can do is you just use the usage I have on the bottom here to actually hide an image within a file. So for example, the first line, it's just Steghide embed, and then the cover file is the file you want to hide the message inside of, and then the embedded file is the file you want to hide inside of it, and then the output file is just the output of that operation. So that will have the cover file with the embedded file inside of it. And then you can also use this to extract messages from a file that you use Steghide for. So Steghide extract, you basically just pass it the output file of the other one, and then it'll give you your message. However, it's also password protected. So this means you can like password protect whatever message you want to put inside of it, and you can leave it blank if you want. But yeah, that's pretty much all there is to Steghide. Stegsolve is basically on the other side of things, where if you think you have some sort of message embedded inside of an image, you can use Stegsolve to potentially figure out what might be in there. So while I talked about least significant bit steganography, there's also lots of other potential ways you can hide things. So for example, you can hide things like only in certain channels, or you can hide things across channels, or you can do things like look at different parts of channels. And basically you can do almost anything with Steghide, where you basically just, and in order to use it, you just use file open the image, and then you can use the arrow keys, or there's also 2 buttons at the bottom that allow you to navigate through these different things. And also if you want to download this, you can download it at that link. And so while you can do like a lot with most tools, there are certain things you can't do, and you might need to like actually write some scripts. So if you want to write a script to maybe like make up your own technique of hiding information, or also to check information within other files, you can use Python's PIL module, and you have basic usage right there. The documentation is also online if you want to look at that. But I would highly encourage doing this because it really gets you to understand how things are hidden inside of information, and it just kind of expands your horizons on the whole like art of steganography.
Awesome. So the last type of steganography that we're going to cover today is audio steganography, which I think is like really, really awesome. So sorry about that. I need to go to the next slide. How do you left click? There we go. Okay. So hiding flags in audio files, it's actually very easy to do so. The good news is that there's many tools that exist already to help you analyze them. So examples are like Audacity and Sonic Visualizer. In the next few slides, I'll go over a few ways that things can be hidden in audio files. So sorry, I'm really struggling. There we go. Okay, so one way that you can hide messages in audio files is through the spectrogram. So a spectrogram is a visual representation of the signal strength or the loudness of a particular thing of audio. And you can actually use that to hide words. So if you see over here, if you take the audio file on the left and then isolate one, you actually can see that there's a message hidden within the audio. And the cool thing about this is just listening to the audio file, you won't be able to. That's not good. Nice. Okay. So the cool thing about audio steganography is like just listening to the audio file, you wouldn't be able to really like hear what the code is. You don't have to speak in an encrypted way or like with a secret language or anything like that. You can just directly hide things inside. And yeah, so other possibilities of ways that things can be is maybe the flag could be reversed. It could be sped up, slowed down, layered into audio. There's a lot of possibilities that you cannot hear what they're saying. And you can manipulate the file in some way to be able to into something that's by human ears. Just listening to these files, typically sometimes you can't hear them at all if it's hidden within like layered with another file. You might not even be able to hear. You have to isolate a specific channel that the flag is hidden in. Sometimes it'll just sound like static or something of like high pitched beeping or screeching sound. So completely unintelligible to the human ear. That's why the tools I talked about before, like to analyze spectrograms and to be able to manipulate the file by like reversing it, by pitching it up, pitching it down, stuff like that, is very, very helpful in audio steganography. Oh shoot, sorry. Yeah, this is another tool that's very useful. It's called Sound Exchange. And this is a command line tool for audio manipulation. It's one of many options. Like I said before, Audacity, like different spectrogram viewers all exist, and you can use that instead if you prefer to have like some kind of like interactive GUI. So Sound Exchange has a lot of functionalities. You can convert audio files to other formats. You can apply various effects to the files. Like I said before, the flag may be hidden, and you can adjust the audio speed to try to find it. You can try to concatenate two audios, mix them together, change their pitch, reverse them. There's a lot of possibilities. If you want to read more, I've linked their page to their like documentation there. And the other thing about Sound Exchange is you can also play and record audio. So very, very powerful tool. And it sure would be a shame if we hid some flags in audio files during the CTF part. Yeah, so do you guys have any questions about any part of our presentation?
You said that you would hide information. No, that's me.
Okay.
I have any questions? Or probably type in the chat. We're having a hard time hearing people. All right, if not, then this is the end of our presentation. If you go to acmcyber.com, there should be some challenges there in the challenges section specific to steganography that you can attempt to solve if you want. And if you have any questions on how to try and solve those, you can either ask us here now, or maybe if you're trying to solve them later, then DM us on or ping us on Discord, and we'll try and answer your questions. So that's that. Thank you for coming, everyone, and yeah, let's tackle this down.